Again, when you are dealing with an identity, what you're trying to do is make two sides look like each other. And we do so by using our basic identity conversions. That means anytime I see a tangent, I can replace it with sine over cosine. Or if I see sine over cosine, I can replace it with tangent. Whichever one's going to work the best as I work my way through my equation to try and get things to match. Likewise, cotangent can replace cosine over sine, or vice versa, cosine over sine can replace cotangent. Those are the quotient identities. There are only two of them. They're called the quotient identities because tangent and cotangent are found by taking the quotient of two different trig functions. The reciprocal identities are the flip identities. Those are the ones where you just flip it over and make it equal to the other one. So cosecant can replace 1 over sine, or 1 over sine can replace cosecant. Secant can replace 1 over cosine, you get my gist, right? Cotangent can replace 1 over tangent, 1 over tangent can replace cotangent. The last are the Pythagorean identities, and actually we're going to spend the most time right now on the Pythagorean identities before we jump into our actual identity work. The main Pythagorean identity is this very first one. And if you never memorize anything else, this is the guy you should know. You should always remember that cosine squared plus sine squared equals 1. Why? Because on our unit circle, if I draw any triangle, and I'm just keeping it to the first quadrant. Remember, this is a unit circle, right? I drew a triangle formed from an angle. This point on the unit circle is the coordinate xy. Good? So far feeling me? The radius of the circle is always 1, making the hypotenuse always 1. And the length of the bottom is x, and the height of the triangle is y, and according to Pythagorean theorem, x squared plus y squared equals 1 squared, or the radius squared, correct? Makes sense? But when we talk trig, the x is cosine, and the y is sine. Therefore, I can interchange x with x squared. That's what identities are all about. Substituting something that has an equivalent value. And so I can substitute cosine in for x and sine in for y, and we know 1 squared is 1. So that's where that Pythagorean, the original Pythagorean identity came from. Just from the unit circle, using the Pythagorean theorem, equating our x and our y to cosine and sine. I do want to address this notation. Cosine squared theta, and I'll write it up at the top of my paper. So I'm going to slide this up. Cosine squared theta, sine squared theta, all of those. When we write it like this, it is exactly the same as cosine theta squared. Why do we write the squared next to the trig function? Because if we don't put parentheses around it and we just put it on the angle, it looks like it's the cosine of the angle squared. So we have to make sure that we understand that we're squaring the cosine. It is cosine theta times cosine theta, not cosine theta times theta. Do you see the difference? Okay. So this is the notation that we use. If it were a third power, I'd put a little 3 there. If it's a fourth power, I'd put a little 4 there, but get comfortable with that. We put it before the angle so we don't confuse the angle being squared over the trig. All right, so back to our Pythagorean identity. Cosine squared plus sine squared equals 1 has a different variation that is adjusted just by doing algebra. And that means if I want to get sine squared alone, algebraically, I would just subtract cosine squared, right? that make sense? Just like any other equation. Go back to like way back in algebra. Sometimes we dream of being back there. If I want to get x alone, I remove the thing that was by x by subtracting it. Same thing here. If I want to get sine squared alone, I remove the cosine squared by subtracting it. That means sine squared theta is equal to 1 minus cosine squared theta. So that is a variation of this same original identity that we are allowed to use. That means if I ever see sine squared theta, I can replace it with 1 minus cosine squared theta, or vice versa. If I see 1 minus cosine squared theta, I can replace it with sine squared theta. We can do the same for cosine squared. Same concept, same idea, same general rule. If I want to get cosine squared alone, I subtract sine squared, meaning cosine squared theta is equal to 1 minus sine squared theta. And again, this is very much puzzle math. I have to look at something and think about what are my options, what can I do, how can I make both sides of my equation look the same using the things I know. These last two here are also variations of this original one that everybody should remember always. Again, if you memorize nothing else, know that one. Cosine squared plus sine squared is 1. The variation here is also algebraic. And so I'm going to move my paper down and make a little work area for myself. So I'm just going to do a scribble. You got lots of room, so feel free to do this. I have cosine squared theta plus sine squared theta equals 1. That's our basic Pythagorean identity. Coming from the unit circle, knowing that the radius is 1, knowing that cosine represents x, sine represents y. If I feel like being a crazy algebra person, I can just go ahead and divide everything in here by the same thing. And somebody might be saying, well, why would you choose to divide by cosine squared? I don't know. Because I can. I don't have a whole lot of other options. I could divide by sine squared, and I will. I could divide by 1, but that's not going to do anything. I don't want to divide by something else that's not going to help me adjust this. So tell me what cosine squared divided by cosine squared is. 1. Anything divided by itself. What is sine squared over cosine squared? What is sine over cosine? Sine squared over cosine squared is tangent squared. What is 1 over cosine squared? Again, what is the reciprocal of cosine? Secant. 1 over cosine squared would be secant squared. We can just do a little movement of this one because it means the same thing. If I flip these around, slide this back up, what do I have? So all I did was some algebra to come up with that next one. These aren't made up. They are found by using algebra. And I can do the same thing with the next one. I'll do it one more time. I have cosine squared plus sine squared. Again, if you remember nothing else, remember this one. It'll show up a lot. We'll use it a lot. If you know it, it'll help you a lot. This time I'm going to divide by sine squared. Again, why? Because I can. And you'll start to see the last thing. Remember, it's fair to do anything. Anything is fair game, as long as you do it to everything along throughout the equation. I could go ahead and I could divide everything by 2 if I felt like I wanted to. Again, it's not going to get me anywhere because I wouldn't be able to simplify anything. So this one I can simplify. This is cotangent squared plus 1 equals cosecant squared. And hopefully you recognize that as the other Pythagorean identity. So all algebra is, all they used to find these other two variations. That is why knowing this one can get you any of these other things just by doing some algebra, okay? All right, whole bunch of talk. Does she ever shut up? No, I don't. I really don't. I'm sorry. Let's go to work. Let's get to some of these identities. This is scary. So all I can say to you is shake it off, jump in, take a look. As a newbie, this isn't always going to be the case, but as a newbie, start by getting everything in terms of our two most comfortable trig functions, sine and cosine. And so that means I'm going to take these and try to get them all in terms of sine and cosine. And so secant is 1 over cosine. These have x's in instead of thetas. Please do not neglect the x. A lot of people do that. It changes it. Sine is nothing without an angle next to it. Actually, sine is just the word sin without an angle next to it. Cosine is just cos without an angle next to it. So don't forget to put the angles next to it. So my secant I rewrite as 1 over cosine. My tangent squared I rewrite as sine squared x over cosine squared x. The other side is already in terms of sine and cosine, so I'm just going to leave those guys as is. All right? So that's my first step. I want to get everything in terms of sine and cosine. Again, as a newbie step, that's the way you should go. And then anything goes. Any rule you have ever done in algebra throughout your entire career as a math person is totally legal. Proportions and cross products are legal. How you divide fractions, totally legal. Anything mathematically that you've ever done, you are free to do. It is scary because it's these letters instead of numbers. But the rules do not change. What does this mean? Be an interpreter. What am I saying? Cosine squared over sine squared. Yeah. This is a division of fractions, and you don't divide by fractions. You do what? Flip and multiply, right? So I take the top, 1 over cosine, and multiply it by the reciprocal of the bottom. It's not something I am used to looking at. It is not a normal thing, seeing all these words. But the process that we did, the math rule that we followed, is completely legal. Then I look at it and see other things that are out there. So dividing fractions, we did that. We flip and multiply. Canceling fractions, also legal. The bottom of this first fraction means I have a cosine of x in the denominator, and the top means I have 2 cosines of x in the numerator, and that's a factor of each, which means I can cross out 1 from the denominator, replacing it with 1, and I can cross out 1 from the numerator of the next one, leaving me with only 1 cosine. And then I simplify, because that's what I can do in math. 1 times cosine is cosine. 1 times sine squared is sine squared. And then, like I said, my goal is to get them to match. The problems that I give you will all be able to be done in 4 or less moves at their minimum. If you start working and you're at like 5 moves and you're not going anywhere, it doesn't mean you're wrong, but I would turn around, start over, and try again. And there are many, many times that I have done that. And I don't use pencil, I use pen a lot. I'll scribble it out, I'll go back and I'll start again, because they should happen fairly quickly. So let's move on to our next one. Again, distributing, cross products, all of those things mean the same thing. And there are a whole bunch of different ways to go about things. And everybody sees things slightly differently. But again, my first recommendation is to try and write things in terms of sine and cosine. So for this one, I'm going to do 1 over cosine x, because that's what secant is, minus 1 equals. I know this is sort of a, I don't even know why people say it, to kill 2 birds with 1 stone kind of thing. Does that make people uncomfortable? I'm going to do 2 steps at once. So I rewrote this, and I'm going to break apart this fraction. This bothers people a little bit. But I'm going to do it first, and then I'm going to talk about it, okay? So I'm going to rewrite this as 1 over cosine x minus cosine x over cosine x. When I add or subtract fractions, remember, if I have 1/3 plus 1/3, it equals 2/3, right? Agreed? So if I had 1/3 plus x over 3, that would just be 1 plus x over 3, correct? Make sense? So if I have this form, what's to stop me from moving it back into this form? And when I move it back into this form, does anybody see what I just did? Anybody see anything that can be simplified? I got some head shakes, no, but anybody?
Cross out the 2 cosines.
Yeah. What is anything over itself? Always. 1. What do I got over here? 1 in that second spot. So again, I'm not making up rules. I'm not changing rules. I'm applying any rule that's out there. Now, sometimes we get like bothered when we see too much stuff going on at once, but especially in these, sometimes I think it's nice to see there are other options for things. So I'm going to do this problem a total different way, just to remind you that there are multiple ways to do things. You can write it down or not, I don't care, but please watch. So here's the other way. And this is not the only other way. There could be 5 or 6 different ways to do this problem. That's why don't be afraid. Just jump in. Here's my other way. I start off with secant x minus 1 equals 1 minus cosine x over cosine x. I'm going to put secant x minus 1 over 1. Again, why? Because I can. Because it's totally legal for me to do that. I can put anything over 1. And it doesn't change the value. And then I'm going to multiply diagonally. Again, why would I do that? I don't have any reason other than I can. It's legal for me to do that. What is 1 times 1 minus cosine? Just 1 minus cosine. What is cosine times secant minus 1? It is cosine times secant minus 1. All right, now I'm going to do another thing. Totally legal. It's always been illegal ever since you started algebra. I can distribute. I'm going to go ahead and distribute. This doesn't change. It looks weird, yes. But all I did was multiply cosine x times secant x, and then I multiplied cosine x times 1. Wait, you said change everything to sine and cosine first. You can. As a new person doing these, that is a great option, but it's not the only option. At this point is where I might change it. Secant is 1 over cosine. So what I have here is cosine over 1 times 1 over cosine minus cosine equals 1 minus cosine. And I think hopefully you guys are finishing with me. What do I get when I multiply cosine over 1 times 1 over cosine? It's 1, because it's cosine over cosine, so I get 1 minus cosine equals 1 minus cosine. They are the same. Now, do they look the same as the first way that I did it? No. So if you are looking at somebody else's paper and you have two different answers, it doesn't mean either of you are wrong. It means you went a different way. Also notice this first one I got done in 2 steps. This next one took me 1, 2, 3, 4 steps to do. So different methods are going to take you different directions. All right? Just jump in and try. Okay. Let's see what we got here. I just want to ask anybody have a thought on where to start on number 3? And there is more than one right answer, so Johnny, what do you think? Okay, put those in terms of 1 over sine and 1 over cosine. Great. So this is 1 over cosine squared over 1 minus sine squared over cosine squared equals 1 over cosine squared minus sine squared. Super. Once we did that, now we have kind of limited our options, but I am a huge fan of cross products. What are you thinking?
I was thinking to flip and multiply.
To flip and multiply here. The only reason I can't yet is because I don't have a common denominator. I have to have one fraction, but then I could do that. Yeah, but I'm not going to do that there. But I am going to say I like the cross products, so I want to go with the cross products. Whenever I get like really complicated, I just multiply diagonal and see what I get. So 1 times 1 minus sine squared over cosine is 1 minus sine squared over cosine. Are we okay with that? My other cross product is, keep in mind that I can put this over 1, so when I'm multiplying these two fractions together, I will get cosine squared x minus sine squared x over cosine squared x. I really do like the cross products if I can use them. They clean things up nicely, especially when I have some complex fractions. Sometimes it's unavoidable. I'm going to have to find common denominators, but sometimes we can do. Speaking of common denominators, I'm going to do a common denominator method with this one. In the previous problem, I broke apart the fraction, and some of your eyes might be going there. If I break apart this fraction, I'll get cosine squared over cosine squared, which is 1, minus sine squared over cosine squared, and I'd be done. But I'm going to do common denominators again. Why? Because I can. And I'm going to do that over here on the right or left-hand side. 1 can be rewritten as cosine squared over cosine squared. Do you guys agree with me? which gives me the same denominator, which means I can write this as cosine squared minus sine squared over cosine squared, and magically, I am matching. Again, my goal is to make them match. Whether they match the person sitting next to you or not, doesn't matter. It's got to match on your paper. Okay, that's what you're working towards. Why are you ripping apart a rose? Yeah. What happened? Oh, okay. All right. Any questions? Any thoughts? You guys want to vent? Anything? It is like no mixed reviews on this one. The only thing I can tell you is like everything else. The more you practice, the better you get. Yes?
How did you get the cosine squared x over cosine squared x?
This was 1. I have a 1 you can see underneath here.
Yeah.
And I can change 1 into 3 over 3, 10 over 10, x over x, anything over itself. I chose cosine squared over cosine squared because that was the denominator of the other fraction, which allowed me to combine them. Because you can't add or subtract without having a common denominator. Does that make sense? I could have chose anything. Remember, I said before, I can divide things by 2, I can multiply by 8, as long as I do it to everything. Here, 1 can be rewritten as anything that's going to benefit me, and cosine squared over cosine squared was the way to go. Okay? The other thing you could have done, like I said, is in the last one, is break apart this second fraction, and then you would have gotten the 1 that the other way. All right. We're going to do one more together, and then I'm going to have you try one on your own, and it's a nice one. It's not too bad. Okay? So, like I had said before, a nice way to start is to change everything in terms of sine and cosine, but sometimes I prefer to simplify a little bit if I can before I do that. And one of my methods of simplifying is distributing. And I did that already, the distributive property, and I'm going to do it again here. So I take the cosecant times 1 and the cosecant times cosecant. Anything times 1 is itself. Anything times itself is itself squared. Anybody see anything they want me to do with the second half, or should I leave it as is? I'll let you guys decide. Should I break it down into 2 separate fractions, or should I leave it as one solid fraction? One answer is not better than the other. What seems to jump out at anybody? No comment? Then I'll leave it. So this is sine x minus 1. Sometimes no comment is, we just don't know. You have to be daring here. Jump in and try something. Okay, so I distributed. Again, you said change everything to sine and cosine. Yes, it's a good call, but maybe I would distribute before I do that. So I'm going to do that now. Cosecant x is 1 over sine x minus 1 over sine squared x equals sine x minus 1 over sine squared x. I just kept that again the same because nobody said do otherwise. Remember, my option would be to separate this. It would be sine x over sine x squared, or sine squared x, minus 1 over sine squared x. But if I'm going to keep it together, what do I need to do here to get these to go together? To combine fractions, I need what? Common denominator. What is the least common denominator? Sine squared, yeah. So I need to multiply this guy by sine x, giving me sine x over sine squared x minus 1 over sine squared x equals sine x minus 1 over sine squared x. When I add fractions or subtract fractions, I just add or subtract the numerator and the like common denominator stays the same. So this would be sine x minus 1 over sine squared x, and lo and behold, I've got that guy. Okay, again, I'm going to do this. I'm going to point over here, write this down or don't. You don't have to if you don't want to. But at this level, I could have done cosecant x minus cosecant squared x equals sine x over sine squared x minus 1 over sine squared x. That's breaking apart the fraction. And then when I write them like I did over here, 1 over sine x minus 1 over sine squared x, I could be done by reducing 1 over sine x minus 1 over sine squared x. Okay? So that would be, again, another option. This is one option. This is a second option. One way is not better than the other. It's kind of personal preference, and sometimes it just takes diving in and getting used to the water. All right? So let's have you do the next one. I bet there are some of you who have already done it where you're like, I got this one. The answers could look very different. So in the first way, I did my cross products. Like I said, I tend to be a big fan of the cross products. Then I changed, and then I ended up with 1 equals 1. But if you change right away, flip and multiply, you can get down to here. One thing that I notice people do a lot, especially if they're unsure about this, is they write a whole bunch of like jibber jabber, and then all of a sudden they put sine equals sine at the end. Just know that I look at them very closely, okay? So work should be shown to some extent. You don't have to go crazy. Like I didn't write this as 1 over cosine divided by 1 over sine, like with the division symbol, and then flip and multiply, and then do it. You don't have to show every step. I didn't write this as cosine over cosine and sine over sine and then reduce them. So some of the steps are skippable, but as long as I can follow your progress. The other thing that you have to be really careful of, and this is absolutely allowed, you will lose points. Notice how I work myself down with an equal sign between them. And I rewrite both sides every time, even if I didn't adjust it. That is a necessary step. That's what identities are all about. It should have steps with an equal sign down the middle all the way through until they look the same. Don't just drop one half, not write it. You need to be very organized. If I can't follow your progress, then you won't get full credit for it, okay? Any questions? How many were able to get this to work? Did anybody do it a different way than the 2 ways that I did? No? Okay. All right, so let's do our next one. Let's bring in some of those other identities. And we're actually probably going to just do 2 more. And then you guys are going to work on homework, give it a try, see how you do. But these are the last 2 we're going to do. So I gave you that whole sheet of identities. And I said to you, you don't have to memorize them all. But especially if you have it handy, use it. So for example, in the next problem, I have a 1 plus tangent squared, which is the same as a tangent squared plus 1. This is equivalent to secant squared, and so I can write this as secant squared over tangent equals 1 over sine cosine. Do you have to? No. But watch out for things like that because you can. And then once I'm here, I want to take anybody's input. What should I do? Yeah, who-
Change the secant squared to 1 over cosine.
okay, super. Should I hit the tangent while I'm at it too?
Yeah.
Notice I'm not being lazy. I'm remembering my x's all the way through. I'm bringing my equal sign down. I'm rewriting so I have both things happening on each side. Now what? Got it? Go ahead. Say it again, please. No, I think I know what you're doing. I just want you to say it one more time. Okay?
Times by sine over the other side.
So you're gonna multiply the sign over. Okay. Fine. So Johnny thought I'll multiply by sine, and I'll multiply over here by sine. Now this is a fraction over a fraction. I don't have to multiply it to the top and the bottom. This is my fraction over 1. Fraction over 1. The sine x's cancel out. Okay? So now what I have is sine x over cosine squared x over sine x over cosine x equals 1 over cosine x, and I ran out of room, and that's fine. Good. But how does that help me? It does. I just have to do a little more. What's my little more? Probably flip and multiply, yeah. Yep. So that makes this guy here, because that's a super complicated fraction, becomes sine x over cosine squared x times the reciprocal, which is cosine x over sine x, and then 1 over cosine. And again, I hope you start seeing, all of a sudden, like you start doing these, and all of a sudden it's like, oh, it all opens up, and you're like, oh, I can do that. Anybody feeling it? Oh, what can I do?
You can cancel out the 2 signs,
I can cancel out the 2 signs for sure. Anything else?
and then you can cancel out like the singular cosine, but if the other one is the singular cosine.
For sure. What am I left with? Which is exactly what I want. Okay? Again, is this the only way? Nope. Is it a way? Yep. Did we get what we wanted? For sure. And that's our goal. All right. The last one we're doing together. And again, I'm going to show you another little technique that involves using these. It doesn't mean you have to, but it is a way that you can do this. And the more you do, the easier it gets. And again, I'm focusing on that tangent squared plus 1 equals secant squared. That means anytime I see a secant squared, this secant squared, I'm going to highlight it, that I wrote over, I can replace it with tangent squared plus 1. Okay? Because they are equal. And sometimes it looks a little more complicated at first, but in the long run, it will clean up kind of nicely. Does anybody see why I might have done that? What can I do algebraically?
The tans cancel out.
Yeah. This is tangent squared x minus tangent squared x, gone. So they cancel each other out. Gone and gone. That leaves me with 1 plus secant x. I'm going to go here and I'm going to revisit that simplifying or breaking down that fraction again because it's a technique I like and I think it saves time. This is cosine x over cosine x plus 1 over cosine x. Again, just breaking apart the fraction. I'm not breaking any rules. If I add together fractions, I just add their numerators and their common denominator stays the same as long as they have a common denominator. And then I can go into that step where I rewrite and simplify. Again, your goal is a maximum of 4 steps. There are problems that you might even be able to knock out in 1 or 2 steps. We are going to work more on this tomorrow. And for tonight's homework, I'm going to give you, again, a little bit of an adjusted assignment. If I can find my homework packet. I think I gave somebody my last homework packet. Let me see. Yeah, I would love to. Awesome. Thank you. I appreciate that, Courtney. How about let's do 47 to 50. Let's just go 47 to 52. That's it for tonight. 47 to 52. That is it for your homework tonight. 47 to 52 on section 3.